Students, here there is another problem based on the variable mass system. Let's read the question first. And it says that a mass m1 is connected by a weightless cable. This mass m1 has been connected with a weightless cable passing over a frictionless pulley to a container of water. This is left hand side water there, and its mass is m0 at t is equal to 0. If the container ejects water in the downward direction at a constant set b kg per second with a velocity of v0 relative to the container, determine the acceleration of m1 as a function of time. So we have to calculate the acceleration of this. So what are things quantity has been given to us is that number one is given that this liquid is coming out with a velocity v0, constant velocity v0 relative to the container. Second thing what is given to us is equal to dm by dt is equal to b kg per second, b kg per second. So while first step of solving the problem is drawing the free body diagram, so we'll draw the free body diagram first. So the right hand side, the block free body diagram, the one m1g force will be there. There will be tension will be there away from the body. Similarly, if you draw this container containing water, then what will happen? This will be m1g will be there. Suppose at any time it will be mg. Mass will not be m0. M0 is the initial mass. Some water is going out, and there will be tension here. But as the liquid is going out, it will exert another force called the thrust. And it is coming with some relative velocity. So if thrust will be there, the thrust I given the name th. Okay. So we know that we have to calculate the thrust and the mass, and very simple, mass of the left hand system is equal to initial mass m0 minus it is going out the b rate mein to bt. This much kg will be there. And second thing is thrust force is equal to when the dm by dt into v relative, the magnetic thrust force. So this dm by dt is given the b, and the v relative given the question is the v0. So thrust is equal to the magnitude of b v0. So these are the two quantities we know, and we'll proceed right now to write the equation of motion. So this equation m1g t there, and here t m1g and thrust is there. So we'll write the equation of motion. So right hand system m1g minus t is equal to m1 into a acceleration, and for right hand side t minus mg. What is m? m0 minus bt into g plus there is a thrust is there upward direction, so plus b v0 thrust is there, and this is equal to mass of the system is equal to m0 minus bt into acceleration, and by constant relation we know the acceleration of both the body m1g and this has to be same by the constant relation, so that we have done a is equal to a. Now this simultaneous equation has to be solved. To solve this, what we will do, we'll add this both two equations. When we add this t1 t and t will be cancelled, so what will remain with the m1g minus m0g plus bgt plus b v0 is equal to m0 minus bt into a. Let's see what the question is saying. Question is saying calculate the acceleration of the as a function of time. So we'll see, we'll calculate. So acceleration has to be found out. So this acceleration can be written as m1 minus m0 into g plus bgt plus b and v0 by m0 minus bt. So this is the answer we got as with the acceleration as a function of time. You put substitute the value of time here, you will get the acceleration at any point of time. Let's check whether the answer is correct or not. So m1 minus m naught g b plus bgt plus bv naught by m naught minus bt. Let's check. m1 minus m naught g plus bvt plus bgt plus m1 plus m naught minus bt. So the answer is correct.